Okay, welcome to this class today. In today's class, we are going to consider solution to physics questions, and this is going to be on the standard of the question that you should be expecting in your various examination, be it school exam, WAEC exam, NECO exam, JAM exam, IJMB, JUPEP, and A-level exams. So we are going to start from the simple aspects and take you to the advanced aspects so that you can have a good understanding of what each question is talking about. And when you look at this question that we have here as the first question, the question says that a man walks a distance of 3 kilometers in 20 minutes. Calculate his average speed. Now, how do you calculate the average speed? The first thing we need to ask is, what is average speed? So when you talk about average speed, it's talking about distance over time. And here we are going to talk about change in distance divided by change in time. Change in time. And from there we can see that this is also equals to final distance minus initial distance divided by final time minus initial time. Now this distance is measured in meter and the time is measured in seconds. So the SI unit of speed is meter per seconds, or written like mx minus 1, like that. So you can see that this is given as 3 kilometers and this is 20 minutes. That means the distance that we are given here, the distance x is equals to 3 kilometers, while the time t equals to 20 minutes. So you are going to convert the kilometer to meter, and it's going to be 3 multiplied by 1000 meters, because 1000 meters equals to 1 kilometer. And also this is going to be 20 times 60 seconds, because 60 seconds make 1 minute. So we are going to have here 3000 meters, and we are going to have here, this is going to be 1200 seconds. So therefore average speed is going to be 3000 divided by 1200. 3000 meters, 1200 seconds. 0 cancel 0, 0 cancel 0. Here you have 6 goes here, 2, 6 goes in 30, 5. And that's going to give us 5 meters over 2 seconds. And that's going to give us 2.5 meters per second. And that's how you calculate the speed based on the question that you are given. Hope you understand the way we have solved it. Let's see what we have in the second. Let's see what we have for question number 2. For question number 2, the question says that a man traveling at a speed of 115 kilometers per hour received a text message on his phone. How far is he in kilometers 20 seconds later from when he received the text? Now let's see how we are going to solve the question. We have the solution. We are given the speed, but the speed is given here as 115 kilometers per hour. Now we are given the time t is equals to 20 seconds. Then we are calculating the distance x, we don't know. And we are given the time in seconds, while we are given the speed in kilometer per hour. But we are looking for the distance in kilometer. That means we are going to first convert the 20 seconds to hour. But we know that 3,600 seconds is what equals to 1 hour. So when you have 20 seconds, it's going to be x hour. Then from here we can see that x is going to be, we are going to have 20 over 3,600. And from here you can have 0 cancel 0, 2 goes there 1, 2 goes in 360 is 180. So therefore the time is going to be 1 over 180 hour. So from here we can now calculate the distance, because we know that speed also is equals to distance over time. And from here we can see that distance is going to be speed multiplied by time. So now what is the speed? The speed is, so now we are looking at distance, because you have the speed now to be 115 kilometer per hour, then multiply by 1 over 180 hour. So the hour will cancel the hour here. So what we have left is going to be 115 divided by 180 in kilometer. So you can leave the answer this way, or you express it in decimal, and that's going to give us 0.639 kilometer. And that's how we solve the question. Hope you understand that. Let's see what we have in the next question. Okay, for question number 3, we have this question that a body accelerates uniformly from rest at the rate of 3 meters per second square for 8 seconds. Calculate the distance covered by the body during the acceleration. So how do you solve this question? Now, firstly, we have some parameters that we are given. And what are these parameters? We have the first one, that a body accelerates from rest, meaning that the initial velocity is equals to 0. And also we are given the acceleration. Acceleration is equals to 3 meters per second square. And we are given the time. The time is 8 seconds. And you are asked to calculate the distance covered. That is x. Now, when you look at the equation of motions, probably we have the first equation of motion to be equals to u plus at. We also have x is equals to ut plus half at square, and we have v square equals to u square plus 2ax. These are the 3 equations of motion, although we always have this relationship which we also use in the derivation of the equation of motion. That means v plus u over 2. That means average speed times time is equals to distance. Average speed times time is equals to distance. So we can also use this while we are working with this question. But when you are talking about this particular question that we have, we want to find the value of the distance. And you could see that the 4 parameters we have here are all present in the second equation. That means there is no final velocity. So therefore, the distance we are asked to calculate is going to be x equals to ut plus half at squared. Now the u is 0. That means 0 times t, which is 8. That's the ut. Then plus half times A, 3, then times T, that's 8 square. So this is going to be 0 plus, now this is going to be 1 over 2 times 3 times 8 is 64. 2 goes here 1, 2 goes in 64, 32. So we are having 3 times 32. That was going to give us 96 meter. The unit of distance is in meter. That's 96 meter. So therefore, we can say the distance covered, or let's say x, which is the distance covered, is equals to 96 meter. And that's how we calculate that. Okay, let's see what we have in the next question. Number 4 question says that the motion of an object moving in a straight line is uniformly retarded so that it comes to rest in 20 seconds after traveling a distance of 40 meters. What is the initial velocity of the body? Now, when you look at this question, we can solve this question two ways. Now, the first one says that, or in the first way that we can look at it, let's see what we have as the parameters. What are we given? We have the given data. And what are the given data that we are considering here? We have told that about the motion of an object moving in a straight line is uniformly retarded so that it comes to rest. Because it's uniformly retarding, the final velocity is going to be 0. The final velocity v is going to be 0. And so that it comes to rest in time t, the time t is equals to 20 seconds. And traveling a distance, you are given the distance x to be equals to 40 meter. Then what is the initial velocity? That means u. That's what we are looking for. Now we can apply the formula, and the formula is average speed times time equals to distance, or we can say distance s is equals to average speed multiplied by time. And when you talk about the average speed is going to be v plus u over 2, then multiplied by the time equals to the distance. So in this case, we are looking for the initial velocity, and we know that the final velocity is equals to 0. So it's 0 plus u over 2, then multiply by, that's times the time, which is 20, is equals to the distance, which is 40. So from here you can see that u plus 0 is going to be u, and that's u over, we are having u over 2 times 20 equals to 40. 2 cancel 2 here, and that's 10. So we have 10u equals to 40. Then divide both sides by 10. This by 10. Then 10 cancel 10. Therefore, u equals to 4 meter per second. That's it. Also, we know that when we plot the graph of, because the motion as a body is a body of, the motion of an object moving in a straight line, uniformly retarded. So when it's uniformly retarded, we can put it this way, or better still, we can still draw it this way. We can redraw it this way, that is uniformly retarded. You have this, and is uniformly retarded. Now, this is the u, which is the height, and because this is velocity, we are dealing here with velocity, and this point is time. And the time that we are given in the question is 20 seconds. So area under the graph is what is equals to the distance. And this shape is a triangle. That means half base times height equals to the distance, which is 40. And you have half times base. The base is 20 multiplied by the height, 8, is equals to 40. Then from here you can see that 2 goes there 1, 2 goes there 10. Therefore, we are still having the same thing. 10 8 equals to 40 over 10 over 10. So the 8, which is equals to the initial velocity, is equals to what? 4 meter per second. Because this, you can see this. And that is how you do it also. Either you use the graph or you use the formula to solve it. You're still going to get 4 meter per second. Hope you understand the question. We are still solving more questions, but if you are understanding or you are getting the question right, ensure you subscribe to this channel. This is Covenant Tutor, where we'll be solving various questions for you in mathematics, physics, chemistry, and other subjects. Now, these are physics questions that we are considering, and this covers for every student as far as you are offering physics in your senior secondary school, GS1, SS1 rather, SS2, and SS3. Even for WAEC students, JAM students, NECO students, and all other exams that require physics. So ensure you subscribe to get more information from this physics solution. Now let's see what we have in the next question. Now question number 5 says that what force is required to cause a body of mass 10 kilograms to accelerate uniformly from rest across a smooth surface to a velocity of 50 meters per second in 10 seconds. Now you have to neglect air resistance. Now, what are the parameters that we are given that we are quickly going to look at? We have the given data. We are given the mass of the body. Mass of the body is 10 kilogram, and the acceleration, it accelerates uniformly from rest, meaning that the initial velocity that's u equals to 0 across its smooth surface to a velocity of, that means the final velocity v equals to 50 meter per second, and the time is equals to 10 seconds. Now from here we are going to see that we are going to find the acceleration before we can calculate the force, because force, as you know, force F equals to mass times acceleration. So we are given the mass already, then we need the acceleration. So from here we know that acceleration is equals to change in velocity over time. And from there we could see that the change in velocity is going to be v minus u over t. And what's our v? Our v equals to 50 meter per second minus 0 over t, 10 seconds. So in that case, you're having 50 over 10. Then 0 cancels 0, and that gives us 5 meter per second square. And once you know that the acceleration is 5 meter per second square, we have said it here that the force is equals to mass times acceleration. So mass, as we are given, is 10 kilogram, then times acceleration, which is 5 meter per second square, and this will give us 50 newton. That's the unit of force, 50 newton, and that's how you calculate your force as the case may be. That's 50 Newton. So you can see the way we have calculated our force based on the question you are asked. So let's see how we solve more questions. Okay, number 6 question is: a particle accelerates uniformly from rest at 6 meters per second square for 8 seconds and then decelerates uniformly to rest in the next 5 seconds. Determine the magnitude of the deceleration. Now, let's see how we are going to solve this question. We have the solution. Let's quickly represent this in a graph and let's see what will happen there. Now, in the velocity time graph, we are told that the body accelerates uniformly and then decelerates. So we are given the acceleration to be 6 meters per second. And the time at which it accelerated to 6 meters per second is also given to be 8 seconds, because this is velocity time graph. This is the velocity in meter per second, and we have here the time in seconds. Now, and then decelerate uniformly to rest in the next 5 seconds. That means he spent 5 seconds here to decelerate, and here is going to be 13. Now, from what we have here, we want to calculate the magnitude of the deceleration here. Now, remember that this is the acceleration, which is 6 meters per second square, but we are not given the final velocity here, which we have to calculate first. The final velocity here, v. But we have the following information for the first stage of acceleration. Acceleration is given as 6 meters per second square. We are given the initial velocity because it also starts from rest here. So that means u there also is going to be 0. And now we have the time t to attain that final velocity is 8. That's 8 seconds. So from the equation of motion, we know that v equals to u plus at, because those are the parameters that we are given. So from here, we know that v equals to 0 plus a. A here is 6, then multiply by time, which is 8. Therefore, the final velocity is equals to 48 meters per second. That's the final velocity. But that is not the question we are asked to calculate. Now, that is the first stage. And the question now says, then decelerate uniformly to rest in the next 5 seconds. So at this point where when the object is decelerating, the final velocity here is going to be 0, and the initial velocity is going to be the value of the final velocity, which is 48 meters per second. So we can now use that to determine the deceleration, because now we have the parameters too. Now, in the second stage, we also have that the final velocity now is equal to 0. The initial velocity is now equal to 48 meters per second. And the time is now 5 seconds. So we are asked to calculate the deceleration, which is a. That's what we want to calculate. So here we can see that also v equals to u plus at, and v here is equals to 0 plus 48 equals to 48 plus a, then multiply by t, which is 5. So from here we are having minus 48 equals to 5a. Divide both side by 5, this by 5. So 5 cancel 5. So our deceleration is equals to minus 5 goes in 48. That's 9.6 meters per second square. So that's how we calculate the deceleration, as minus 9.6 times 20, 9.6 meters per second square. Now, if the question says retardation, now if you have retardation, for retardation, we are going to write it as just A. Retardation negates the negative. So it's going to be A equals to, or retardation equals to 9.6 meter per second square. So that's different between when we say it is retarded. That means calculating retardation and calculating deceleration. Deceleration means you are going to indicate your negative, and that is how we calculate it. So do you see how it has been explained step by step on how to calculate the deceleration? Once again, subscribe to this channel. Let's see what we have in the next question. Number 7 question is, a boy which is uniformly retarded comes to rest in 5 seconds after traveling a distance of 10 meters. What is the initial velocity? A boy which is uniformly retarded comes to rest in 5 seconds after traveling a distance of 10 meters. Then what is the initial velocity? Now, let's see how we are going to solve that question. In this case, let's see what we are given as the parameters. So we have the solution. Here we have the given data. The information we are given that the boy which is uniformly retarded, and since we are told that it's uniformly retarded, it means that the final velocity v equals to 0, because it's uniformly retarded to rest, and the time of retardation is given as 5 seconds, and the distance at which it travels, the distance x is equals to 10 meters. Then from here we could see that we want to calculate the initial velocity. Now we know from the equation of motion that v equals to u plus at, and from here we can get the value for the acceleration. So once you get the value for acceleration here, although it's going to be in terms of the unknown variable. Now let's see, we have 0 equals to u, which we don't know, plus a. Actually we don't know a also, because we are not given the value of the retardation. That means a multiplied by the t, which is now what? 5. So from here we could see that we can have that 0 is equals to u plus 5a. Then we can say that what is a? A is going to be minus u over 5. So because from here you can see that u minus u is equals to 5a. Then a is going to be minus u over 5. Now let's keep this as acceleration, and here you have the unknown too, which is u. Now we are given the distance covered here. That means we can also look at it that v square is equals to u square plus 2as. And from here we all know that the initial velocity has been given to be equals to 0, because when you see that also we are going to see from the fact that the initial final velocity is equals to 0. So here we have 0 is equals to u square plus 2 into bracket our a. Our a is minus u over 5. Then the distance that you are given is 10. So from here we can say that 5 goes here 1, 5 goes here 2. So here we have 0 equals to u squared minus, because minus times plus is going to be minus. Minus what? That's 4u. Then from here, we can see that if the minus 4u comes here, so we have 4u equals to u squared. Then divide both sides by what? U. This by u. So u cancel u, and u cancel one of these u. Therefore, the initial velocity is going to be 4.0 meter per second. And that's how we calculate it. Now, do you see how we calculate the initial velocity? From the information we are given that a boy which is uniformly retarded comes to rest in 5 seconds. That means for the boy to uniformly retard, the final velocity is equals to 0. And the initial velocity is supposed to be the value of the final velocity, but we are not given the initial velocity, neither are we given the final velocity, but we are given the time at which it is being retarded to 0. So in that case, then the distance it covers in the course of retarding is 10 meters. Then what is the initial velocity? So from the information that we have, the final velocity is 0, the time is 5 seconds, the distance covered is 10 meters. So we can calculate the value of the deceleration in times of u, and that is what we have here. So we can now substitute this into the third equation. That means the velocity, which is the final velocity, is still 0, and u, that's what we are looking for. And we have the deceleration now, which is minus u over 5. Then from here, we are also given the distance, which is 10. We have calculated out or work out the value of u, and that is how we calculate or get the answer. Hope you understand that. Peradventure, if you have any question, check the link or the description below. You are going to see the contact to call or to ask further question. Now, question number 8. A palm fruit drops to the ground from the top of a palm tree 80 meters tall. How long does it take to reach the ground? Now, here, this is motion under gravity. And we have it that a palm fruit dropped to the ground. From here, we are going to look at some correlation with the normal equation of motion. Now, we are going to take the further because this one we are given the height. This is 80 meters tall. That means distance is equals to height because we are going to be using this. And also from here, because it dropped from the height, the initial velocity is equals to 0. Because the palm fruit drops, that means it is at rest before it drops. And then we are going to see that acceleration here is going to be taken as g, which is acceleration due to gravity, because this is a vertical motion. Then from here, we have seen that how long, that's time. We are asked to calculate the time. And from what we are given so far, we can see that x is equals to ut plus half at squared. Then relating with what we have here, that means we are going to have h is equals to, what is u? Is 0. 0 times t will become 0. So you see have it as ut plus half, that's 1 over 2 times g, then times t squared. So here, our u is equals to 0. That means we have h to be equals to half gt squared. And now we are asked to calculate the time. So from here, we can substitute the parameters, or we can make t the subject. So when you multiply both sides by 2 here, you are going to have 2h is equals to gt squared. Then from here, we can see that t squared is equals to 2h over g. And from here, we can see that our t is going to be the square root of 2h over g. So let's take note of that formula, and we are going to apply that here. So here we are saying that t equals to the square root of 2 times h. What was the h? 80 divided by g, which is 10. And from what we can see there, we can see that 0 cancels 0, and that's going to give us the square root of 16. That means t is equals to 4 seconds. And that's how we calculate that question. You can see how we relate the normal equation of motion to motion under gravity, and how we use that to solve the question that we are given here. So let's see what we have in the next question. Now, question number 9. A car travels with a velocity of 18 km per hour. It then accelerates uniformly and travels a distance of 50 meters. If the velocity reached is 54 km per hour, find the acceleration and the time to travel this distance. Now, let's see what the parameters that we are given. Looking at it, solution, we have that a car travels with a velocity. That's the initial velocity. Initial velocity. That's u equals to 18 kilometers per hour. It then accelerates uniformly and travel a distance. So the distance here, that's x. Distance x equals to 50 meters. If the velocity reached, that's the final velocity. Final velocity, and that is our v, equals to 54 kilometers per hour. Find the acceleration and the time to travel this distance. Now, we have to convert this kilometer per hour to meter per second and see how we are going to do the conversion. Now, for 18, here we have 18 kilometer over hour. Now, we can see that this is kilometer per hour. That's kilometer over hour. Then we are going to multiply. What do we have here as a denominator? It's hour. That means 1 hour, because the hour will cancel the hour. Then 1 hour equals to 3,600 seconds. As you know that 60 seconds make 1 minute and 60 minutes make 1 hour. In that case, that means we have 60 seconds is 1 minute and 60 minutes is 1 hour. That means 60 times 60 seconds will give us 1 hour, and that is 3,600 seconds will give us 1 hour. So 1 hour over 3,600 seconds is still the same thing. It will cancel out. That means 1 hour equals to 3,600 seconds. Then multiply by, now numerator. What we have in the numerator is kilometer. So we are going to have that 1,000 meters over 1 kilometer. 1,000 meters also equals to 1 kilometer. As you can see, 1 hour is equals to 3,600 seconds. That means 1 hour and 3,600 seconds, they are both the same, so they will cancel out. That's 1. 1,000 meter and 1 kilometer are also the same. They will cancel out. That's 1. So it has no effect on what we have here. We are just converting. So from here, we could see that 0 cancels 0, 0 cancels 0. 18 goes here is 1. 18 goes in 36 is 2. 2 goes in 2 is 1, and 2 goes in 10 is 5. So that means 18 kilometers per hour is equals to 5 meters per second. The same thing we are going to do for 54. Here we have 54 kilometers over hour. So it's going to be times, we are going to multiply that times, for hour, 1 hour over 3,600 seconds, because you can see from here, hour will cancel hour, kilometer will cancel kilometer. So what is left is meter over seconds. That's meter per second. And this one also is going to be times 1,000 meters over 1 kilometer. Kilometer will also cancel kilometer. Hour will cancel hour. Then here also we have 0, 0, 0, 0. Here we can see that 9 goes in 54 is 6. 9 goes in 36 is 4. Also, 2 goes here, 2. 2 goes in 6, that's 3. And 2 goes here, 1. 2 goes in 5. In 10, that is 5. So 3 times 5 is 15. So this one also will give us 15 meter per second. So we've converted the initial velocity from 18 km per hour to 5 meter per second, and the final velocity from 54 km per hour to 15 meter per second. Now we are now asked to find the acceleration. We want to find the acceleration. So how do we calculate the acceleration? From the equation of motion, we know that we are given the following parameters. That means when you use the third equation, which is v squared equals to u squared plus 2ax. A is what we are looking for here. So here we can say that a is equals to v squared minus u squared over 2x. And what is v squared? Then we are having here, that's 15 square minus 5 square divided by 2 into bracket 50. So 15 square is 225. 225 minus 25, then divided by 100. And this one will give us 200 over 100. And that will give us 2 meter per second square. That's the acceleration, 2 meters per second square. Then from there, we can calculate the time, because I have to find the time of traveling as well. So let's see how we are going to use this space here, probably to calculate the time. Okay, for the time, we can use the first equation of motion, that is v equals to u plus at, because we have all the parameters now except t. So the final velocity is 15 equals to 5, which is the initial velocity, plus a, that's 2, then times t. We are looking for t. So here we can see that 15 minus 5 equals to 2t. So 2t equals to 10. Then t is equals to 10 over 2, and that is 5 seconds. And that's how we solve for the time, and that's how we solve for the acceleration. I hope you can see the way we have even converted the kilometer per hour to meter per second, and how we use the equation of motions to actually solve the question as you are given. So let's see what we have in the next question. Question number 10 says that a ball is thrown vertically upward from the ground with a velocity of 20 meters per second. Calculate the maximum height reached. That's A. B, the time to reach the maximum height. And C, the time to reach the ground again after the ball is thrown up. And D, the velocity reached halfway to the maximum height. And we are given that acceleration due to gravity is 10 meters per second square. So let's see how we are going to solve this fantastic question. And here we have. Okay, now what we are given here is we are given that a ball is thrown vertically up from the ground. Here we can see that as the ball is thrown vertically up from the ground, The first thing we need to establish is that our A is equals to minus G, because the ball is being thrown vertically upward from the ground. And here also, the ball gets, like the question says, calculate the maximum height reached. At the maximum height, the final velocity is equals to 0. And the initial velocity u is going to be the 20 meters per second as we are given. So from here, we are using the equation of motion. That's the third equation of motion. And that means also that our x, which is the distance, is equals to height. We use height to represent that. So from v square equals to u square plus 2gh. In that case, we are going to have 0 equals to 20 square plus 2 into brackets. You know, our a is minus g, and that's minus 10. Then times the height, which is what we are looking for. Then from here, we can see that 0 equals to 400 minus 20h. So minus 20h is coming here, become 20h equals to 400. Then h is equals to 400 over 20. That means the maximum height is equals to 20 meters. 20 meters. That's how to calculate the maximum height. Then the next question B says that the time to reach the maximum height. The time to reach the maximum height. Now, in this case, we are still using the same relationship, knowing fully that we want to calculate the time. And also, our V equals to 0 and our U is equals to 20 meter per second. Also, our A is equals to minus G. So using V equals to U plus AT, that implies that we have 0 equals to 20 plus minus 10t. So 0 equals to 20 plus times minus, that's minus 10t. So from here, we could see that 10t equals to 20. And when you divide both sides by 10, so we can get our time to be equals to 2 seconds. 2 seconds. Now, the next question, which is C, says the time to reach the ground again after the ball is thrown up. Now, the same time it takes the ball to reach the maximum height is going to be the same time to return back to the ground. So for option for C, it is still the same time. That means t is equals to what? 2 seconds, because it takes the same time to reach the maximum height to return back to the original height. That's what we are going to use to calculate the time. We can as well use the equation of motion. And when you are using the equation of motion, that means x equals to u t plus half at squared. But the condition here is that we are going to take our a to be equal to 10 meters per second, 10 meters per second square. So let's see how we could solve that question for C. Because of our space, let's try to remove this part. Okay, now for C, we said the time taken to reach the maximum height is also equal to the time taken to return, which is 2. But we can as well use x is equals to ut plus half at squared. And when you are using that, we are going to pick or note that the initial velocity here is equals to 0. And our a is going to be 10 meter per second square. So from here, we see that our x is known. We've calculated our x, which is the distance or the height attained, and we have gotten that to be 20. That means our x is equals to 20 meter. So from here you can see that s is equals to ut plus half at square, and that's going to be, ut is equals to 0, so it's going to be 1/2 times a, that's 10, then multiply by t square, and that's what we are looking for. Remember that our x is what? Is 20. Is 20. So from here, when you cross multiply, 2 goes here 1, 2 goes here 5. So we have 20 equals to 5t square. Divide by 5, and this also by 5. So this by 5. So in that case, you are seeing that our t square is equals to 4. Then t is equals to the square root of 4, and that also gives us 2 seconds. 2 seconds. You can see the way we have worked that out. 2 seconds. So for C, that's time taken to return back to the ground is 2 seconds, just like we have it. Then the next thing we want to look at is the D part. So let's quickly see how we are going to solve the D part. From the information that we have worked and calculate so far, we want to calculate something here. Okay. Now, the velocity reached halfway to the maximum height. The maximum height, s, is 20 meters. So velocity reached halfway. That means when you say velocity reached halfway, that means our x in that case, let's say x1, is going to be x over 2. That's 20 over 2, and that is 10 meters. And from there, we can also use the equation of motion, the third equation of motion, to as well do that. And when we use that, we are going to use v square equals to u square plus 2ax. V square equals to u square plus 2ax. And as we know, all our conditions are still intact, because at this point we want to calculate the final velocity here. We have our initial velocity, our acceleration, and the distance. So our u here is still going to be what we have as 20 meters per second. Then we have our a to be equal to minus g, and then we have our x, which is now 10 meters. So if we substitute that from here, we have v square is equals to u square, that's 20 square plus 2 into bracket minus 10, then times 10. So here you are going to have 400, that's plus times minus is minus, 2 times 10, that's 20 times 10, that's 200. So therefore, v square is equals to 400 minus 200, that is going to be 200. We have it as 200. Then we have 200. So therefore, v equals to the square root of 200, and that gives us 14.14 meter per second. And that's how we get the formula. Now, as we have solved these questions from 1 to 10, if you have learned one or two things, ensure you subscribed, as more questions will be uploaded. Now check the description below to get some other information. And likewise, I want you to subscribe to this channel. This is Covenant Tutors, where we solve various questions from different aspects and subjects, such as mathematics, physics, and chemistry. And also, we also know that this is meant for students both in school, for normal school examination, how to practice with them, and also for any external examination. It can be WAEC, NECO GC, GC, JAM, IJMB, and GPEP. So these are the contents that we are providing for you. This is Covenant Tutors, where we have quality content and quality education. If you have any question, like I said, deem free to reach out to us as the comment section, and ensure you subscribe, press the bell button, and press the thumb up button to get more information. Thank you.